So here we are, lesson 115, exponential equations, exponential functions, and compound interest. You notice we skipped lesson 114 just because I feel this is more important. We don't have a whole lot of time left. Alright, so what if I had 10 squared equals 10 to the x power? Okay. One of the things that you know is that if this is a 2, this also has to be a 2 because 10 squared is 100. And what exponent do I put up here to also give me 100? 2. So that gives me an observation here that if I have two bases that are equal, then the exponents also have to be equal. So that helps things for me because let's say that I have something crazy like 10 to the 1.23 and I say that's equal to 10 to the x plus 2. Alright, so what that tells me is because my bases are equal, my exponents are equal. So 1.23 equals x plus 2. And if I subtract 2 from both sides, I can find out what x is there. Okay, so that is something that's very, very important dealing with, again, that scary word, logarithms. So let's look at some ways to make that usable for us. So we're going to look at example 115.1. I have 17 equals 10 to the x plus 2. Alright, problem here is I can't find this unless this 17 and 10 are the same number, and in this case it would be nice if this was this 17 was a 10. So if I write this as 10 to some power, then I can say that power equals this. So I'm trying to change this 17 to a 10. So how in the world do I change a 17 to a 10? Well, if I take the log of 17, what that means is, what exponent can I put on? Remember, it's an assumed 10 down here. I'll put it down here just to help you. Okay, so what exponent can I put on 10 that will give me 17? So if I just type in my calculator log of 17, that will tell me what exponent I can put on 10 that will give me 17. And it's 1.23. So I can rewrite 17 as 10 to the 1.23. Pretty cool thing here. Well, only math geeks would think it's cool. So I change that 17 to this. By taking the logarithm, I'm saying, alright, when I take the logarithm, I'm saying, I'm going to change the base to a 10, and what number will I put on 10 to give me 17? And it's this. Now I can say 1.23 equals x plus 2. I do my math, and I find out that x equals negative 0.77. And I found what my variable is when it's in that exponent position. Okay? Alright, so if we are doing something crazy in biology or chemistry or something, sometimes we want to know the growth of bacteria. Sometimes in economics we want to find out interest when we put money in the bank or in stock market, how much money we're going to make off of that. And we have what is called exponential functions. Exponential means that it either grows or gets smaller very, very quickly. So rather than go through all the theory in this chapter, which can be very, very confusing, let's just get started with one of the examples here. And we've got just a couple of examples, I think 3 of them. Alright, so 115.2, in the beginning there were 400 bacteria in the dish. Alright, first of all, let's go ahead and write the equation for exponents here as far as exponential functions and equations. Alright, it's a to the subscript t, a. That o is an o. I don't know if it's a 0 or an O, but anyway, well, I'll explain what it means here in a minute. There's the formula. So because we've got exponents up there that are variables, sometimes you're going to have to use logarithms. Alright, so what this means is the amount in a certain amount of time, the amount we started with, E, meaning that is that number 2.8 da 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 da, or your ln key. K represents, let's see, what does K represent? I think K is a constant, and then T is the amount of time. So anyway, let's get started on this and see what we can do here. Alright, so in the beginning there were 400 bacteria. In the beginning, so that means 400 goes here because that was the original amount of bacteria. The number of bacteria increased exponentially, which means we're going to use this formula. 3 days later, okay, so my time is going to be 3. 3 days later, there were 2,000 bacteria, so my amount after that time was 2,000. How many bacteria would there be in 8 days? Alright, so what I'm going to do here, it's a two-step process. First of all, I have to find K using the information they give me initially. Okay, and after I find K, then I'll change this to an 8 days and then be able to find out how many bacteria I have in 8 days. So this is how many bacteria I have in 3 days. And once I find K, then I'll plug the number K here, and I can find out when I change this to 8 how many bacteria I'll have in 8 days. So what I'm going to do is I'm going to come up with a formula so that I can put any number here I want and find out how many bacteria I have. So I could put a 12 in here and find out how many bacteria, an 18 and find out how many bacteria. But first of all, I have to come up with the formula based on this information they gave me as far as how fast the bacteria grow. Alright, so after we find K, we'll throw out the 3 and the 2,000. Those will go away. Alright, so let's go ahead and see if we can figure out what our K is. So we're going to take this and divide by 400, divide this by 400 to get that 400 out of there. So I have 5 equals e to the 3k. Okay, I just switched the k and the 3 around. Doesn't really matter. Alright, so remember what I said in the section earlier. I said if we want to find out this variable, it has to equal this variable if the bases are the same. My one base is a 5, not an e. So what I'm going to do is I'm going to take the ln of 5, and when I do that I get e to the 1.61 power, and that equals e to the 3k power. Okay, so see what happened there? I took the ln of 5, or basically I took the log e of 5, and that equals what I'm looking for there, my exponent. Okay, so I'm saying what exponent can I put on e that's going to give me 5? And why did I use ln instead of log? Well, this is an e. Whenever you have an e involved, you're using ln rather than log. Okay, so once I did that, then I am able to find my k, and I find my k very easily. Let's move that up here, because these are the same now. I can say 1.61 equals 3k, divide by 3, divide by 3, and I get k equals 0.537. So in the book, I just used the 2,000 and the 3 days in order to find my k. Now I'm going to take my original problem here, and let's get rid of this junk here that I don't really need anymore. Okay, so I don't need any of this anymore, and I'm going to take this formula here, and I'm going to say AT, because this I'm looking at, well, actually I'm not going to put AT, I'm going to put 8 just to remind myself that I'm looking at 8 days. So I have 400 E, and I found out my K was 0.537. Multiply that by 8 days, and I'll go from there. Okay, so multiply those two. 8 times 0.537 is 4.296. Okay, and then I'm going to find the answer of that. So what I do for that is I take my 4.296 and I push my anti-log key, because I'm not looking for the exponent, I'm looking for what this equals, and that equals 73.4. Multiply that through and I'm done, and I get 29,362. So what I've done then is I've come up with a formula right here based on 2,000 bacteria in 3 days, based on that, how quick that bacteria grows. Some bacteria might grow 10,000 bacteria in 3 days, but this one is 2,000 in 3 days. So because of that, it's only used in this particular instance. I can put any number I want in here and find out how many bacteria I will have in that many days of that particular bacteria that grows that fast. Alright, so let's move on to example 115.3 in the next video.